Find the x and y intercepts and the vertical, horizontal, or slant asymptotes for the function. So here we have the function f of x equals 2x squared plus x minus 10 all over 2x squared plus 11x plus 12. It's easiest to do these things if you have the function both in factored form and expanded form. So I'm going to start this process out just by factoring my polynomials in the numerator and denominator. So in the numerator, I have 2 times x would multiply to give me 2x. Or sorry, 2x times x is what I meant to say. And that would multiply to give me 2x squared. And then 5 and 2 would give me 10. So I'll put a 5 here and a 2 there. I wouldn't put the 2 here because that would give me a common factor between these constants. So that's not likely to be how it will factor. All right, so 5x and 4x, if the 5 is positive and the 4 is negative, they'll add up to positive x. So there's that. The denominator, again, 2x and x multiply to give me 2x squared. For 12, there's a few different possibilities. 6 and 2, although both of those have common factors of 2, so let me try 3 and 4 instead. And I'll put the 3 with the 2 because 4 has a common factor with 2. All right, so this would be 3x and this would be 8x. Oh, and if they're both positive, they can add up to 11x. There we go. Okay, so x-intercepts. X-intercepts, where they occur, is zeros of the numerator. All right, so in my numerator, if I set these factors equal to 0 and solve, those will give me the locations of x-intercepts. So if I take 2x plus 5 and set it to 0, I get an x-intercept of negative 5 halves. And of course, it has an accompanying y value of 0. If I take x minus 2 and set that to 0, then I get positive 2 with a y value of 0. So those are my x-intercepts. Y-intercepts. Y-intercepts occur at the ratio of constants. So there's only one, and you just take the two constants in your equation and you take their ratio. So it's got an x value of 0, because for y-intercepts, you're always solving f of 0. And in this case, it turns out to be negative 10 over 12, which reduces to, let's see, negative 5/6. Horizontal asymptotes, there's some different rules on horizontal asymptotes. In this case, the degrees of the numerator and denominator are equal. So when the degrees are equal, we take the ratio of the leading term coefficients. So we say y equals the ratio of leading term coefficients, with which both happen to be 2. So in this case, we have y equals 1. Now, if we have a if we have a horizontal asymptote, that rules out the possibility of a slant asymptote. You can't have both a horizontal and slant asymptote, so one of those two is not going to exist. Now, vertical asymptotes. Vertical asymptotes, these occur at the zeros of the denominator. So it's similar to the x-intercepts, but we're just taking the factors in the denominator and setting those to 0 and solving. But also, these are vertical lines, so we don't write them as points. So if I take 2x plus 3 and set it to 0, I get x equals negative 3 halves. If I take x plus 4 and set it to 0 and solve, I would get x equals negative 4. Now, if you want to see where I'm getting these things, I'm just taking the factor itself setting it to 0, and then solving the linear equation. So if I subtract 3 from both sides, I get 2x equals -3. And then if I divide both sides by 2, x equals -3/2. And that's what I've done for all of the zeros of the numerator and denominator.